Hi, welcome everybody. My name is Dino Esposito. Andrea.
My name is Andrea.
Saltarello is here to help and to share even more insights about domain-driven design and patterns that help us doing this kind of design in .NET. Before we officially start, as there's still people coming in, just a quick note, sort of a disclaimer, for those of you, I don't know how many people are here, who attended yesterday my pre-con. Okay, there are quite a few. But anyway, the point is the content you're going to get now with this content and the content I covered yesterday in the first half, there is a significant overlapping. So that's it. We have a few different demos, but no, the talk takes probably some different routes, but the overlapping is still significant. Well, there is a very blazing, beautiful view from this angle, very crowded room. I guess that there are no other dev sessions concurrently running, probably. So all devs are here. Good. To be perfect, the room should be crowded also in that angle out there. That's an uncovered area. Okay, let's officially start the talk. What we are really talking about, so what you will find out of this session. Ddd Analysis Patterns. This means covering things like ubiquitous language and why the ubiquitous language is key, such a key thing for architects and developers as well. The point I want to make is just showing you for all those analysis patterns, ubiquitous language, bounded context, and context maps, our effort will be just showing you where is the ROI, where are the money, where is the point of doing DDD, which is a lot more, well, sophisticated thing that is often summarized in tutorials, books, articles, and things like that. And in particular, we are making the point of neatly separating what is the analysis part of DDD with those patterns and the architecture, or which supporting architecture you happen to use when you actually move to the next step of physically building the system. So supporting architectures, the most popular architectures today are domain model, CQRS, and event sourcing. The reason why CQRS and event sourcing on this slide are grayed out is that we don't cover specifically, we mentioned, but don't cover specifically those in this talk, but we have a talk tomorrow where we focus exclusively on those architectures, and this session is clearly preliminary to attending the talk of tomorrow. But anyway, the key takeaway out of the content we are sharing today is that in our vision, which is, by the way, reflected in a book for which we have some free copies to pick up at the booth this afternoon, at the DevTools booth, is that it's time for developers and architects to move beyond the domain model supporting architecture and move steadily towards a different architecture, CQRS. And these are just the topics being covered in a related session B313 tomorrow afternoon. Ddd Analysis Patterns. Now, the fundamental thing is that DDD, domain-driven design, is a methodology that literally, domain-driven design, serves the purpose of helping you to design a system driven by the characteristics of the domain, of the business domain. So it all means that out of your preliminary analysis, you figure out processes, entities, relationships, things that happen and how they happen in the observable domain, and you just try to render them via software. So we write software ultimately to mirror what we observe in the real world. This is, a much subtler point that you may look at first, because typically developers have a huge ego. We love to look smart. We feel like we are God. So when we face typically the task of modeling something, the common mistake we make is, okay, I'm God. How would I create this business? How would I recreate, reshape this particular business model? And this takes us in conflict with how things go really in the real world, with how customers, stakeholders expect things to go. This is reflected by a huge number of incoherent, ambiguous, unclear requirements, which are partly like this by design, because no customers on the face of the heart will ever be able to deliver requirements which are not ambiguous, unclear, and incoherent. But beyond that, there is what architects do or don't do to try to make sense and figure out what is the real mechanics of the system emerging out of those unclear, incoherent, and ambiguous requirements. So it's a sort of a 50-50 situation. So to address this kind of issue, DDD helps with its analysis patterns. DDD as a methodology has now, subsequently, two distinct parts. You always need one, and you can happily ignore the other. But happily ignore the other doesn't mean that the other part is wrong or deadly wrong or inefficient or whatever bad adjective you want to use. It's simply that there is a lot more value in the first part, which is the one that we recommend you always take into account. The part of DDD that you always need is the analytical part. The other part is the strategic part. Analytical is valuable to everybody and every project. It has to do with a collection of patterns to work out the top-level architecture of the system. Once you have done this, the second part, the strategic part, gives you advice on which is the best, preferable, recommended supporting architecture to actually build pieces you identified in the top-level architecture. So the juice of DDD, as we say things, is in the analysis. To conduct an analysis with DDD, we essentially rely on two pillars. One is called the ubiquitous language. At the end of the day, the ubiquitous language is essentially a simple vocabulary of terms. Terms means verbs, means nouns, means adverbs. Probably we can get rid of adjectives, but nouns, verbs, and even adverbs are key. This vocabulary essentially should be shared, must be ideally shared by all involved parties, all parties involved in the project, stakeholders, consumers, architects, project managers, all kind of people, and should be used, those terms should be used in all written and spoken forms of communication. This is key. This is a sort of preliminary. Along with the ubiquitous language, there is a bounded context. What is a bounded context? It's essentially an area of the domain. So you essentially split the whole domain representing the business you have to model in software in smaller pieces. It's the classic divide and impera motto that people in history, from Julius Caesar to Napoleon, applied successfully to rule the world. And bounded contexts are here to help you rule your software project, which is a much, much less ambitious goal. What's that? The bounded contexts in a domain are something that you discover as you understand more and more about the project. So the bounded context is not something that is there for you to figure out, for you to see. They are there for you as an architect to understand requirements and figure out which blocks of code form, working together, the whole system, but can be implemented using a unique, specific set of technologies and even programming languages. More about the ubiquitous language. So they are words and verbs which reflect the true semantics of the business. It's the classic example we make usually is, imagine you are involved in an online store, website or application, whatever. You have orders to deal with, and orders are entities, logical entities that support a number of actions, operations, one of which could be just canceling the order. So now the point is that user interacting with the system, all it does is creating and possibly canceling the order. But when this process is implemented, when you create an order, a workflow starts that spans across the entire back end of the system, checking payment histories of customers and a few other things. At the end of the story, it will definitely create a few records on a few database tables. When you cancel the order, you probably end up deleting a record. But if you go to a customer and mention that you are deleting an order, you are raising a possible misunderstanding which can have serious consequences, because you don't delete a record in a business, but you probably cancel an order. So the point of the ubiquitous language is avoid using expressions like delete a record, so verbs like delete, nouns like record, but in the business use for delete, cancel, and for record and order. Is it simply a matter of a table conversion? Yes and no, because depending on the context, the verb you use to describe business-wise the action of deleting something can be cancel if we are talking about an order, but can be another verb if we refer, for example, to a customer. it could be maybe remove the customer, unsubscribe the customer. So the physical action is still doing some delete operation on a database, but business-wise, it's a different set of terms, nouns and verbs that are great to use. So in the end, the ubiquitous language is a mix resulting from the space of terms used by domain experts and the terms known and familiar to dev teams. Ubiquitous language mixes all of them. In which way? There is definitely the vast majority of entries we have in this ubiquitous language dictionary refer to key business concepts. No other way. The vast majority is business related. But however, you should expect to have the need of having in this vocabulary also some terms that map to more technical actions. Because at the end of the day, we are still building a software system. So when it comes to cross-cutting concerns, security, caching, persistence, well, it might be that you need to introduce to spoil the pure ubiquitous language with more technical terms. Okay, I promised to show you the ROI of a ubiquitous language. Let's explore a couple of scenarios where using the pattern of the ubiquitous language is beneficial. In first place, it is beneficial, highly beneficial, when you really have a lot of domain logic to deal with, where when and where the domain, the business domain, is complex. And complex, by complex, I mean full of business rules. And to give you numbers, I mean hundreds of business rules that sometimes are related to a single logical entity, in some other cases span across multiple logical entities. When complexity is high, it's key to ensure that all relevant terms are understood correctly. It's key to ensure that there is a clear procedure that takes you out of the mess or shows you the way to go. Think for a moment to pilots who fly you from place to place, airport to airport. There are so many things that can happen when you fly. And there are a bunch of things which are common, but there are always exceptions. Undesired, unpleasant side effects, right? Events. So for what is feasible to imagine, they have a procedure. So ubiquitous language is like the procedure book that pilots have when they fly, and that tell them what to do whenever an unusual event takes place. And in a large, complex, sophisticated collection of business rules, there is always something that you have missed, something that you have misunderstood, a requirement that didn't come the right way on your desk, or that you forgot. There are so many events, and ubiquitous language gives, okay, what do you mean by this? And that makes it easy and clear to understand each other. No other terms outside the vocabulary should be ideally used in the communication, and each term should be unambiguous. So if you mean delete, it means delete an order, it means canceling an order. So no duplication, no ambiguity. Another scenario is when you really have business logic that is unclear. Startups. Think of startups. If you are helping, if you are engaged, involved in building software in a startup environment, it may happen that the business, the final destination of the software is not clear when you start. Or maybe it's clear, but it changes as new insights about the business or new ideas show up. Think also of the classic agile iteration. You deliver a working build, the customers look at the build, oh, and they got inspired to ask for more. Or they revise some of the concepts that they explained even clearly to you, and they ask for more. So in this scenario, making sure that we are talking about the same thing and meaning the same concept using a given word is absolutely clear.
Now what?
Now what?
Now what? Okay. What Dino just did is to explain us where the ubiquitous language does shine. Okay? What I'm going to tell you is where the ubiquitous language is going to several developer lives instead. Okay? We do run a small company in Italy, and we do work on real-world projects. And what if you go to a client of yours and discover that this client is used to call users what you call customers? And what if your client is used to call administrators the very representative of customers, and you end up having such a naming clash? So you go to analysis meeting and you have users and stakeholders talk about users and administrators, and you start thinking about users such as people having a username and a password, and to administrators as users which have superpowers, and that's not what your client is telling you. Okay? So you have to solve this kind of a mess in a way or another, and the only way that can supposedly work is to have we technicians adopting the language which the business is talking since maybe ages. Okay? We're not going to force the business to change the terms, the words they're going to use, because, you know, this kind of situations happens in Italy to largest companies. Very large companies do use this kind of jargons. Okay? And you could end up having users, which we mean for user, calling you by the phone in order to have support and telling you, okay, I have a problem when I try to create a new user. Okay? And you start thinking about some kind of security-oriented feature, but it's not telling you about security-oriented feature. It's only telling you that he isn't able to create a new customer in the database. Okay? So you start to try to map what he's telling you to your own code, and you start looking at some kind of dictionary where you've written, okay, every time the user told me about users, I have to look on the create customer instead. Okay? And you lose a lot of time, and you're really going to be mistaken where you speak back to the user. So the only way that will work is to have us technicians adopting the language that the business is speaking all across our stack, even to the code. And that's what we're going to show you a little bit later. Okay?
So the ROI of using extensively a ubiquitous language is avoiding any conflicts, any required translation between the language spoken by customers and the language understood and spoken by developers. This is a language that goes through the entire stack, including and especially, I would say, code. Because the fundamental point of ubiquitous language, which apparently could be taken as something you do in a sort of sprint zero, in a pre-analysis, in a pre-development phase, it's something instead that goes with and proceeds and improves along the way as you take the project towards its natural and final destination. So as you learn more about the system, as you learn more about the domain, it could happen that you feel the need of updating the ubiquitous language, update the vocabulary, and change things, and keep essentially your understanding and the ubiquitous language in sync, but even more importantly, keeping the ubiquitous language, the vocabulary, and the naming conventions you use when you actually write C#, VB, Java code in sync. If you misunderstood the meaning of the word delete, and you figure out that in some scenarios that has to be called cancel, it's your responsibility as an architect to enforce on your developers, or if you are a developer, enforce on yourself, to rename properly what needs to be replaced. Is it too hard, too much of a work? Oh, in a large code base renaming? Oh, well, it could be hard, but there are so many tools, coding assistant tools out there in Visual Studio, around Visual Studio, on top of Visual Studio, that can be leveraged, okay, to make quickly refactoring patterns and especially renaming. So there are really no excuses to not keep in sync ubiquitous language with naming conventions in your code. And when I say naming convention, actually I mean the names you use for your classes or for your functions, for your methods, for your properties. Everything in code has to faithfully represent what happens in the business. And look, when most of the times we look into what we call sometimes modeling, we look into classes, flat classes, with just a collection of properties with public getters and setters. And we call that the union of those classes. Oh, this is a model. And if the model works in a given business domain, we sometimes call that a domain model. Words, pure words. Domain model is just strictly related to having a ubiquitous language. So, look at this screen. Imagine what is on the sticky note could be maybe one of the requirements you get. As a registered customer of the I Buy Stuff online store, I can redeem a voucher for an order I place so that I don't actually pay for the ordered items myself. Nouns and verbs, red and green, but what it means is that this requirement is telling us that the user in this particular requirement is concerned about a thing called the voucher. And voucher is here a business-specific name that we must reflect, must add in the dictionary, physically representing the ubiquitous language. By the way, when I say the dictionary, I say anything like an Excel file where you have, or maybe an access table where you have just a column with the term and another column with the intended meaning, just for your reference. Voucher is a business-specific name, which means that even in your code, any action you code against this logical entity called voucher should use that name. It's not allowed to use any synonyms like coupon or maybe gift card. You never know what happens in 6 months when a bug shows up, or maybe you get a call or you get a request for some enhancements. Voucher means something that the user understands. If you find there gift card, well, it can be confusing. And, well, just to report, numbers shared last week at a conference from the CTO of Capgemini, well, it turns out that problems, errors that are related to bad coding practices have a limited impact on functional issues. They count for maybe less than 10%, but the impact on non-functional aspects like performance, like scalability, like usability reaches up to 85%. So bad coding practices are the problem of modern software development, and anything you can do to at least mitigate the impact of bad coding practices is your ROI. Andrea now shows us, switching to Visual Studio, what it means to model a voucher the right way.
Okay. Now, what we will define as the Ddd Bible is a book written by Eric Evans, who is a Canadian Java developer, in 2004. And I did buy that book. I did already buy Martin Fowler's one, which, to my knowledge, is the first book who refers to the domain model and then to domain-driven design. And I did read those two books, and I just tried to have a clue about how to apply this kind of topics in code, to put them in code. And they both define the domain as a set of clusters of objects, okay? And that isn't surprising because, I mean, both Fowler and Evans are Java developers, okay? Software architects who plays with the Java language. And I told myself, okay, I'm going to use C#. I'm a C# developer, so I do have access to an object-oriented language too. How do I apply this in code? And let's just have a look. So let's add a Voucher Class. Let's zoom it. Yeah. And let's try to think in Ubiquitous Language, okay? And let's think about the very reason a company is going to generate and then maybe sell vouchers. Let's think at the iTunes card, okay? So there is a company that is going to sell products, which are songs or movies or whatever other content is sold by the iTunes store. And this company is going to actually sell these vouchers to stores who are going to sell them to you. And each layer on the business stack on the force is going to have some kind of earning in producing, buying, and selling those vouchers, okay? So those vouchers does exist because they have a value. And then we have a value property. And all vouchers does have an ID. Let's suppose to have it defined as a GoID. And let's try to actually use. Oh, we're smart developers, so we know that the ID is going to be generated by the constructor. So this.id equals new GoID. Now. And then let's try to use our brand new voucher class. var v equals new voucher, and value equals 100 euros. Now, we write it this way, but what the compiler does really generate is this kind of code. And now what? Now we have a voucher instance, a voucher object, that for a short, really short time frame actually has a value of 0. And that's a nonsense from the business point of view, because neither Apple nor another company will ever sustain the costs involved in printing the vouchers and sending them to stores, okay? So we're not going to allow a voucher to have a value of 0. At least when I'm just generating a new voucher, okay? So that's why we end up having maybe this kind of parameter applied to the constructor. And then if value is less of 0, we throw new argument exception. Okay. Wow. Actually, in most countries, vouchers do have to have an expiration date, okay? Because they're not allowed to be kind of a currency, okay? And so we add date time expiration date. Okay, we will be back to the voucher class a little bit later. And our actual implementation of the voucher class does allow us to write this kind of code. Now, if only life was this simple, I cannot actually have a voucher be recharged by only setting a new value to the value property, okay? So I'm going to kind of protect the value property and have the setter be private, okay? And for the very same reason, I'm going to protect the GUID setter. This way, a voucher could be recharged by implementing a recharge method which accepts value. In most countries, vouchers are not allowed to have a value higher than a given amount, okay? So that's where we are supposed to implement our business logic. If this dot value plus amount is greater than, let's say, 5 grand, let's throw new invalid operation exception. Otherwise, we're going to recharge the voucher. Okay. So that becomes a call to the recharge method. Okay. Now what? Now we already told ourselves that we're going to implement the expiration date management for our voucher class. Now, we could say that there are going to exist 2 different types of vouchers, which are the long-term supported ones, and the ones that are going to expire in shorter time frames. This means that the default expiration date is datetime .now.add months. Let's say that long-term vouchers are going to expire a year later. And we also have to accept the expiration date. So we now know that we have to make the setter of the expiration date private and public voucher, int value, date time, expiration date. So this dot ID equals new go ID, and this dot value equals value, and this dot expiration date. Okay. In a real project, I'd go for a little refactoring in order to have one constructor calling the other, and without having code duplication. But we're going to write down code in a really quick date, so I won't bother with such an issue. But I'm still going to check whether the expiration date, desired expiration date, actually happens in the future, because I'm not allowed to generate vouchers which are new vouchers which are already expired. No company will accept the cost involved in generating vouchers that are not going to produce earnings. And let's throw new argument, exception, and I could specify the parameter name, blah, 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 blah. Okay. So we are now able to have new instances of the voucher class generated by specifying both the desired value and the desired now expiration date at months, let's say 3 months. Okay, and sometimes a voucher expiration date can be extended. Okay, a lot of phone carriers in Italy does allow you to buy vouchers and have them both recharged and extended in time. And for the very same reason, we didn't allow the value property to be set by the application. We're not going to allow this kind of code. The expiration date equals v2 expiration date plus add months. Okay. Because we did already apply the private modifier to the setter, to the property setter, and that's why we're going to have public void delay expiration date, date time, expiration date, and some kind of business logic in order blah 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 in order to verify the expiration date. Oh, let's just say months, just for this dot expiration date equals this expiration date add months. Okay. And that's why we're going to call the delay expiration date, and let's say 3. Okay? Now let's just have a look at the very moment in which we do generate the voucher instances. Okay? Let's try to pretend to be the guy who's going to read this code several months after it has been written, and without being the one who did the code. And this guy is going to ask himself, okay, what's the point in this object construction? What's the very meaning in this line of code. Okay? I could just pick the definition, and I have that defined, and maybe I could go for the XML comments. XML comments are wonderful, okay? We should all use them, but what about just avoiding developers to just use the constructor and have factory methods implemented instead? So public static voucher generate long-term voucher int value var v equals new voucher value, return v, and then I'm kind of lazy, sorry. Generate expiring voucher, date time, expiration date, expiration date. This is going to break our compilation, but generate long-term and voucher dot generate expiring vouchers. Okay? This is code that is going to be easy to understand even months after being written. Okay? Let's just have a look at the voucher class now. And maybe this is very different than the class we would end up modeling should we think in entity framework terms or presentation-oriented terms. This is the class we end up defining when we think in terms of the ubiquitous language and the business logic. Okay? And that's a simple example of what you end up defining using domain-driven design modeling techniques. And you end up defining what the domain-driven design calls a domain model. And let's, proceed in talking about DDD.
So essentially, summarizing, the purpose of this voucher demo was making the point that when you write the model for a piece of software that expects to closely model a real business domain, you are actually creating an API. And when you create an API, it's your responsibility to let people using your API just for the tasks, just for the actions that are consistent with the purposes. Now, if you have a voucher class that looks like an anemic class that looks like the database structure, so at some point you have to persist the voucher class somewhere. The data into the voucher class should be persisted, right? And probably you're going to persist those values to a relational table with columns. So you have one column for the ID, one column for the value, one column for the expiration date, and so forth. Now, any class that just is reverse engineered from this table works in the end. It works, period. No doubt, no question. The point is, if you give away as part of your public API for the domain to your team or to other teams or you yourself, months later, you offer a class that after you got an instance, a fresh instance, if you don't manage correctly the constructor through factors or through just the syntax of the constructor, you can have a fresh instance with no value in it, no consistent value in it, no value consistent with the business expectations. If you leave the value as an integer with a public setter, and by the way, this is exactly what you get if you reverse engineer an existing database, or if you just create an anemic, so with no methods, no logic, just attribute-based class, the public setter on the int value property means that any value that the software allows you to put there is any value that is an integer. So from minus billion to billions to plus to billions could be a negative value. So everything, all the checks should be made to prevent those things. But just checking, writing, a custom setter don't work. Because it's a silly solution to say, okay, I mark my setters as private and I just add a method set value. It's the same. We are back to square one. The point is altering the state of any class involved in a domain model using methods that reflect real actions that users of applications based on that model will perform. So if you have a voucher, which are the actions you do on a voucher? You may recharge the voucher. You maybe use the voucher in a transaction. But okay, just to stick to the demo that Andrea showed, an action is recharging the voucher. Recharging the voucher actually just increases the value property. But that happens within the boundaries of the recharge method. And that is the only public interface you offer to the world. That's interesting. So once you have put control over the input value in the recharge method, you're done. No way that people could arbitrarily set the value on a voucher without passing through a recharge. And this, combined with application logic and presentation screens that may enable or disable or prevent certain operations, puts you in the perfect, ideal condition to implement a system that is faithful with, goes along, very well along with the business expectations. This is the ROI, essentially, of the ubiquitous language. Second pattern, bounded context. Now, the first time when you start trying to make sense of requirements to build the ubiquitous language, sometimes you find out that as you talk to people, as you read requirements coming from different departments within especially a large organization, it's not unusual that the same word is used to mean different things. And when this happens, because developers and architects have a huge ego, we think that, oh, it's our fault. We are not able, not smart enough to be able to deal with this contrasting meanings, and we try to build one more and more and more complex domain in which we take care of all possible meanings, and we build up classes with more and more and more responsibilities. Now, even beyond the solid stuff, single page responsibility, single responsibility, blah, 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 even beyond that, the point is that we are putting into a class with a fixed name, different behaviors. So one issue is we are combining too many responsibilities in a single and necessarily bloated, rather bloated object. This is one point. But sometimes, even worse, the two responsibilities we combine together can just multiply exponentially the complexity of the model itself. So sometimes it could be really impossible or nearly impossible to match together two responsibilities. And bounded context is the solution, in the sense that when you figure out that the same term at some point is being used by different people with different meanings, you have probably just crossed the boundary, the invisible boundary that separates what in DDD is called a bounded context. Trying to translate a bounded context is nothing different from a subdomain. So if you have a business domain, well, a bounded context is just a fancy term to indicate a subset, a partition of that originally unique, all-encompassing domain. So you split the domain. This is the essence, the gist of bounded context. Now, imagine you have a model like this with a graph of entities related in some way one to the other. You can have a development team that works and has a certain area of influence on the overall single domain model. Another team may have an influence on another bunch of classes, and there is some overlapping. This is just a graphical diagram-based representation of when the same term, the same objects are being used by different people, different themes, okay, to do different things. The integrity of the whole model, of the top-level architecture, is at risk. Being at risk doesn't mean you screwed up things, but it means you are at risk. You are putting yourself on the way to building a big ball of mud. So the purpose, the point is each diagram here, each area here of different color will be split, and common parts will be replicated in each of the bounded context, because likely in each bounded context those entities will mean something different. Let me give you a concrete example. Imagine a club, a software that manages a club, so bookings, restaurants, this kind of things, administrations, this kind of things. When you, as a user of this, as a member of this club, use the booking software, and you want to book whatever, a place at the restaurant, maybe a court to play tennis, golf, or whatever, you pay to make your reservation. So there is a payment action. But like when you instead go to the club and maybe say that the club has a voucher, again, a rechargeable card that you can use for your expenses within the club. You go there face to face and pay cash just to the admin people, to the back office. That is another action because it modifies, it has a different stream of a different workflow, but it's still called a payment. But in one case, you are paying to book, and that is one action. The other thing is just recharging, but maybe it's still called payment, but it's a recharge. So now it's really hard in this context to imagine you can have a single payment class. Okay, if you dumbly look at the words and create a class for each word, right? This could create significant issues. So in the end, each bounded context is characterized by its own ubiquitous language, its own supporting architecture for the domain, which includes having a model, some sort of a model, and each bounded context, more importantly, the most important thing of all, belongs to a context map. Okay, what's the context map? That's the third thing, the third pattern of Ddd analysis. Just as a note a tip from the trenches, from experience, 99% of the time, when you think, devise, design software for a large organization, the topology of bounded context likely reflects the internal organization of the company, so the various departments they may have around. So it's not that the bounded context is something you have to invent yourself. It's something that is relatively easy to figure out, even though there might be some aspects where, specifically refining, the geography of the borders may be a little bit hard. Now, why we have this map? The point of Ddd is, again, taking you to devise a model that works and faithfully represents a business domain. But again, we are not God. We are not creating that model. We are just trying to find a way to replicate the behavior via software. So all that we need is a model that models the domain. Let's take a look at this map. And in particular, take a look at a couple of geographical areas, Alaska and Brazil. Question for you, is Alaska as large as Brazil? Look at the map and give me your answer. Who thinks that the two countries are more or less the same size? Don't be shy. Okay. So, no. Brazil is effectively 5 times larger than Alaska. Brazil is over 8 million kilometers square. Alaska is 1.5. But if you look at the map, well, this difference doesn't show. So, is the map wrong? It depends. It depends. This map is not a geographical map. It's not the type of map you use with Google. Bing, actually. It's a very old map, okay, created around the 16th century and has been used since for nautical cartography. So if you are now, if your goal, your objective is building software in the domain of nautical cartography, this is the perfect map you want to use. If you are building any other kind of thing that requires Bing maps, okay, this model in that case would be absolutely wrong. Why this map is nice? Because if you imagine you want to go from one place to another, essentially you figure out that the angle between the course you draw as a point-to-point line is always constant across all the parallels. This is the characteristics of this map that basically is based on the idea that each square you see, regardless of the size it has on the map, represents the same geographical area.
Talking about ubiquitous language, this is called loxodromy. Loxodromy.
Okay. No,
this concept.
So in the end, even for the sailors of the 5 centuries ago, calculating the road, the course, whatever, was easy with the protractors because they just get the angle constant and just follow that. Okay, beyond that, I'm not a nautical cartography expert, so I just try to make this easy to understand for you, because this is a great example of the fact that when you build some software, you don't have to look for the objectively right domain, because you're not God, but you have to look for a model that really models effectively the domain you're in. And this is instead the context map. So the final purpose, the final destination of domain-driven design is helping you figure out the top-level architecture. So which subsystems, which blocks form your entire domain and their interrelations. So each of the blocks you see on the slide now represents a possible bounded context for the given domain, and the arcs connecting them represents the relationships between bounded contexts. Now, from the previous slide, we know that each bounded context has its own ubiquitous language, its own implementation, including its own architecture. So each of those blocks can be implemented separately by different themes, or by, if you have bandwidth, the same theme. But also different technologies can be used there. Each technology, each combination of architecture and frameworks and technologies that pays the bill. So don't be afraid of using maybe CRM or a CMS in one of those blocks, or maybe even a plain crude system with 2 tiers, client and server, if that pays the bill. Don't be afraid of using web forms. If you have skilled developers that only can do web forms, but they can do web forms effectively, and web forms with the data grids and data sets pays the bill. But sometimes each of those, by the same token, some of those blocks may require a more sophisticated supporting architectures like domain model, or better, CQRS, or maybe even event sourcing. A few words about the letters you see on the arcs. Now, bounded contexts are not islands. They need, or maybe they can be considered as islands, but they need bridges to connect them to other islands. And bridges have roads, and roads may have signals. So you are responsible for traffic in a way. U and D, for example, in an arc connecting on a context map, bounded context, indicate U stays for upstream and D for downstream. It's essentially, they depict a master-slave or customer-supplier relationship. So the U, in that case, core domain, for example, is more important than back office. And more important here means simply that the team in charge of core domain is assigned by the lead architect the right to make changes to the public interface without worrying too much about the downstream bounded context. And by the same token, vice versa, the team in charge of the back office should always look for changes coming to the public API from the core domain. Because another responsibility of bounded context not explicitly mentioned on the previous slide is that each bounded context should expose a public interface to communicate with other bounded contexts. And this interface could be anything that works for you. It could be a web service. If, for example, any of those is an ASP.NET MVC, it can be a web API set of controllers. It could be a Windows service exposing JSON, or maybe it could be a Windows service that writes something. It could be a shared database. It could be a queue, MSQ, RabbitQ, and service bus, whatever works for you to synchronize and connect and exchange messages between those blocks. Another type of relationship is partner. Essentially, it's a relationship in which the two connected bounded context and development teams work together. They are partners on the same problem. They share the same level of authority, and no changes to the public interface of back office can be made without a mutual agreement with the other partner, and vice versa, of course. And finally, there is the anti-corruption layer, ACL. The anti-corruption layer is used typically when one of the bounded contexts is outside your control. So the company, the software house, the group in charge of the entire system, of which this could be the top-level architecture, you have dependencies on something you don't control. Thinking of a sort of a club site application, I rendered as an external dependency the service that gives you weather forecasts. But you can extend this concept to incorporate also any dependency you may have on third-party frameworks. And in general, all interop scenarios. In this case, well, you really have no control. So your block, club site in this case, is constantly downstream compared to the external dependency. But to mitigate the impact, especially if you figure out that things may change inadvertently, okay, on the remote end, you may introduce an anti-corruption layer which maintains, but it's for your convenience, a sort of constant interface towards the bounded context and massages all changes that may intervene from the external under your control block. This is the anti-corruption layer, essentially a proxy pattern, a proxy in the middle. So, in a nutshell, DDD is primarily about analysis. And for this, it provides great tools. We call patterns in this talk, but choose the name you like. And we are talking about ubiquitous language, bounded context, and context maps. So the final output of a DDD analysis is discovering the top-level architecture and, as an artifact, getting the context map. Okay. And this ends the discussion about the first part, the analytical part of DDD. What's beyond that? You are left with a bunch of bounded contexts, and you have to figure out what is the best way to implement, to turn those logical entities, logical subdomains into something concrete. This is where supporting architectures come into play. And this is also the point that, in our opinion, originated a lot of confusion that is still visible today. Now, DDD was introduced by a book, the Blue Book from Eric Evans. This book was written some 10 years ago. More recently, in I think it's 2009, at a QCon conference in London, the same Eric Evans gave a talk. You can still find the talk, the video of the talk on YouTube. Gave a talk titled "What I Have Learned 5 years later," the book. What I have learned about domain-driven design 5 years later, the book. In this talk, Eric Evans essentially regrets that in the original formulation of DDD and in the order of chapters you see still today if you buy the Blue Book, the role and importance assigned to things like ubiquitous language and bounded context, they come in the second half of the book, and domain model appears to be, because you run as you read earlier into it, to be the most important part of the story. He said, 6 years ago actually, said, look, there should be a different focus, a shift of focus. Ubiquitous language, bounded context, and context maps, these are the analytical part of DDD. Whatever else, and primarily the domain model pattern, become part of the strategy you choose to implement bounded context. So the equation DDD is equivalent to having a domain model in your software is no longer true. They are different things. DDD is analysis, domain model is about strategy, and it's just one of the possible supporting architectures. But there is more. To generalize, even when you choose domain model as your architecture of choice, your supporting architecture of choice for a given bounded context, not necessarily you have to produce an object model with certain characteristics, as Andrea showed, with factories used instead of constructors, with private setters, with value types instead of primitive types, with aggregates and many other of the concepts you may have heard associated with domain model. A domain model is just a model for the domain. It can be based on objects, it can be an object-oriented model, or it can be, why not, a functional model. So the expression domain model is having something that models in an all-encompassing way, so a single framework, a single API you write for the entire model. This is the meaning of the domain model as a supporting architecture. And we say, well, this is one option, but it's probably the least interesting one that you want to look into. What else? We have definitely architectures like, for example, CQRS, or maybe event sourcing, or the two things combined together, CQRS with event sourcing. We are going to talk about just this, and starting from here, in our talk tomorrow, 313, it's the code B313 is the code of the talk. What is the point of CQRS? Is the same inspiring idea that led us to talk today about bounded context. So divide et impera. CQRS, which is not, as DDD, a top-level architecture, it's just an implementation pattern, right? CQRS says, look, why should you care or bother about building a single model for the entire domain? At the end of the day, each software system, this is an idea that I think Bertrand Meyer pushed out several years ago in the beginning. He said, look, any action can be either a command or a query. If it's a command, generically, it just alters the state of the system and typically doesn't return any input back except maybe an ACK. Done, failed, success. If it's a query, it doesn't alter the system, the state of the system, but it just returns data back to to the user interface. So the key idea behind CQRS is, instead of having and building an all-encompassing model, whether object-oriented or functional or whatever else we can think of in the future of software engineering, split comments from query. And CQRS, as an acronym, stands for Command and Query Responsibility Segregation. It's a very simple idea, just like the Columbus egg. So when apparently too simple idea looks so brilliant. But there are so many consequences, positive consequences coming out of this simple change of mind. Because it means, for example, that the complexity of building a domain model collapses down from an order of magnitude that is exponential. In our book, we talk about the complexity of a domain model in terms of the Cartesian product of the complexity of the command and query side. In CQRS, you have a plain sum, 1 plus 1, because you develop, possibly even in parallel, the command stack and the query stack. And each of the stack can have the appropriate set of technologies. Each stack can be optimized depending on the context, for performance, for scalability, for whatever, persistence, I don't know, whatever. And so the simplification of the design is the first benefit you get. The second is that you gain, architecturally speaking, the chance to scale your performance to whatever limit works for you. And you can do that in total security, in total safety, without taking the risk of breaking something somewhere else. So, this is not here. So this is essentially the point of CQRS, and this is why domain model is so popular, because it was referenced in the book, but in the future, looking ahead, there is only, for what we can see, CQRS in our future. Your mic is done. This is just what we're going to talk tomorrow. I think the talk is scheduled to be at 5 in 8 room B, I think. But anyway, you figure it out, okay. Thank you for your time.